actual practices. As Rob mentioned, many cabinets are delivered with casters or leveling feet, and this creates a space underneath the cabinets. Most people tend to think of the hottest location in a cabinet being at the top of the cabinet, but many times in computer rooms, I've found the highest intake temperatures located at the very bottom of the cabinet. Might be the very bottom 1 or 2 U in the cabinet. And this is the result of hot exhaust air circulating underneath the cabinet and flowing into the IT equipment intakes. Now, the problem cannot be solved in many cases by adding more conditioned air or colder conditioned air. It's simply that the exhaust air flowing under the cabinets is displacing the conditioned air that's there and available. So when these openings are sealed, you can see that the intake temperatures have dropped substantially. And these images are the result of detailed CFD analysis of a computer room. And there's a direct relationship between the evenness of intake temperatures and the efficiency of the room. The goal is always to get intake temperatures into all of the IT equipment, every single U, as even as possible. And that will directly relate to how efficient the room can become. So let's take a look at a couple of images of what these actually look like. You know, on the left is obviously a space you've all seen, an open space underneath the cabinet, and sometimes these can be even smaller, you know, just an inch or smaller, and still that can allow a substantial opening for exhaust air to recirculate under the cabinet. So there's a number of different products available that attach both with adhesives and magnets to block this open space and prevent that recirculation of exhaust air. The next example is a little more common, and people are aware of the problems of this one, of course, which is openings in the rows of cabinets. And this CFD analysis of conditions B4 with the area open shows the hot exhaust air circulating through those spaces and causing elevated temperatures along the edges of the cabinets. Not the entire server. The server, if there's inlets across the full face of the server, over farthest from the gap is getting nice cold air, but right next to the gap is getting very hot air. So it's important to consider intake temperatures at a really granular level, because sometimes monitoring or even sensors within the equipment can miss these high intake temperatures in very isolated locations. So once this gap is sealed, the opening is blocked, of course, and now the exhaust air cannot flow through that space, and the conditioned air that's available in the cold aisle can now make it to the inlets of the IT equipment. And it's important to point out that in both the CFD models for the under rack openings and this in-row opening, that there was no change in the amount of conditioned air supplied to the aisle or the temperature of the conditioned air before and after. These before and after images are purely the result of just blocking an opening.
Thanks, Lars. So here's a couple real world examples of installs where you see this type of application. So kind of on the left and in the middle is a kind of a before and after, right? This is using a rigid vertical kind of blanking panel to accommodate the situation. This is in a co-location. It's in a caged environment. You can see a very large building support column there between the end of a rack. This is a new deployment, so there hasn't been any hardware put in. It's actually the perfect time to do containment projects. But there's 48 inches and plus a little bit between the edge of that rack and the cage, right? And so you got the column there. You got kind of a 24-inch wide space and then the column. So what the customer asked us to do, they required vertical rigid panels, and instead of building one that spans 48 inches wide and the height of the cabinet, there's two of them side by side that are kind of attached to the adjacent panel. And the first one can be removed because this is that roll-in consideration I mentioned earlier, where they would like to in the future be able to roll another cabinet in there, so they can just take this panel, the left panel, out put the cabinet in, and reattach the right panel to the end of the cabinet. On the right, this is an Upsite product. It's called a rack gap panel. It's a great product in that it can actually span these gaps. It can span anything from like kind of less than a foot up to almost 5 feet in width. So it's a universal product. It's used for the same application. It's an opaque product, so you've got options there between doing something kind of rigid and designed specifically for a particular cabinet height and an aisle width, or there's something that's a lot more flexible and repurposable in these rack gap panels. So this is the unique scenario, right? So sealing spaces at the ends of the cabinet rows. We're not quite yet talking about doors. So this scenario is more commonly found in retrofit applications where containment perhaps was an afterthought, right? So because most vendors' door designs require that the aisle end cabinets be in alignment or on the same plane for the doors to attach and install properly, even the slightest offset can make the installation a little bit more tricky and will require some means of dealing with and sealing the space. So depending on how subtle, like a few inches, or dramatic, like maybe a whole tile or more, that this offset might be, there are a number of ways to accommodate the scenario. So if structural rigidity of the door needs to be considered, then added bracing may need to be added in addition to just sealing the gap. So what you got going on here in these pictures, kind of in the bottom left in the little inset. So this is another co-location environment. It's a wide aisle, right? You've got a cabinet on the left. You've got a 48-inch wide dual swing doors at the 48-inch width, and then you've got probably another foot to 2 feet of open aisle. And then this thing returns back. You can't see the building column, but it's another one of those big white columns you saw in the previous slide. So we designed a steel enclosure to span the rest of the aisle and return back to the column. And then inside in the insert where you got the 90-degree angle, there's a brace in there so that when these doors close, it doesn't wobble or shake, or just adds into the structural integrity. In the middle there, the larger picture in the middle, so Upsite's got a unique way of addressing this situation as well. So this is called an adjustable mounting post. So this is a rigid metal post that's got a big steel plate that you can mount to the floor, and you can position this post to align the cabinet on the other side of the aisle, or whatever piece of equipment might be. So now you've just created that common plane or alignment that you need to properly attach the doors and make them work. On the right, the last thing is, again, this particular client, again, wanted a rigid panel that you could kind of see through to do the same kind of thing. You can kind of see the doors, and then we return back to cover up what looks like, maybe 27, 28-inch offset there. So there's a variety of ways of accommodating this situation, and just be aware that it can be dealt with, but it's something you need to pay consideration to.